Hey everyone, my name is Hunter, and today I'm going to be making a video for you guys to hopefully be able to help your children. I know a lot of y'all during this pandemic are stuck at home with your children. You have your own jobs to worry about, and you also are having to help your children understand things that normally they'd be learning at school, but now they're having to learn at home. So this video is just going to kind of unpack one of those Common Core standards, and it's going to help you guys hopefully understand it better and help your children understand it better as well. So the standard that we will be talking about today is a 5th grade Common Core standard. It reads, apply the formulas V equals L times W times H and V equals B times H for rectangular prisms to find volumes of right rectangular prisms with whole number edge lengths in the context of solving real world and mathematical problems. So that's kind of a lot all at once. We're just gonna break this down a little bit. So starting off, what are we talking about? We're talking about volume. We're talking about the size of a three-dimensional object. So volume equals length times width times height, and volume equals base times height. And then next we are talking about rectangular prisms. So again, that's a three-dimensional figure. That's why we're using volume. Get into that a little bit more later. And it's applying it to both real world, so something that you can physically see, a real world, connection, and also just a simple mathematical problem. So what exactly are rectangular prisms and right rectangular prisms? What does that mean? So a rectangular prism is simply a solid three-dimensional object which has 6 faces and are rectangles. So you're going to have 6 rectangles all attached together. Those are the 6 faces, and that's going to make your object, again, 3 dimensions. And then what does it mean by right rectangular prism? So when they say right, it's speaking about the angles themselves. All of these sides will be attached to the base and the other sides at right angles. That's what makes it a right rectangular prism. So what does that look like? This right here is a right rectangular prism. You can see 6 faces if you were to count them. Each place where the sides meet the base form right angles. It looks like a straight up uppercase L. That's how you know it's a right angle, 90 degrees. And that's how we classify that. And that's what we're going to be talking about today. And when we speak about whole number edge lengths, right here where it says whole number edge lengths, all they're saying there is we're not going to be using decimals, fractions, anything like that. So what exactly do we mean when we talk about these different equations? So here we have volume equals length times width times height. Again, when we look here, length times width times height. Now, this might seem at first like a completely separate equation when it says volume equals base times height. What do we mean by base? Here you can see the base. I have highlighted base B. This entire area right here is the base. So you notice that's actually the area of length times width. If you remember from two-dimensional figures, trying to find surface area, we simply find length times width. That gives us the surface area of a two-dimensional figure. So that's one side. This is just saying that if we already have length times width, if we already have this base, then we can just do the base times the height. These are both the same thing. This is simply combining length and width into one base. And again, down here, it's two-dimensional. We're dealing with 2 right here. But when we're dealing with these problems with the rectangular prisms, we're dealing with 3 dimensions. We have length and width, but then we also have height. That's our 3rd dimension. All right, so what do rectangular prisms look like in real life? What is a real life example that everybody is familiar with that we can use? So I think that a fish tank is a perfect example. We have a rectangular prism. Usually there are different sizes of fish tanks, but most fish tanks are one shape, and everybody's familiar with them at any age. A lot of children even have one in their classroom already at school. It's just a great example. Everyone's familiar with it, so let's see what that looks like mathematically. Okay, so using that fish tank example from before, let's look at what a problem might look like, and let's go ahead and solve that. So This example right here says, Jimmy is trying to decide if he has enough room for a fish tank. The fish tank that he wants is 4 feet long, 2 feet wide, and 2 feet tall. How many cubic feet of space does the fish tank take up? So again, we were talking about three-dimensional figures. That's why we have cubic feet. That's important. If we were talking about 2 dimensions, it's squared. So using squared with a 2 rather than cubed with a 3. Volume is always going to be cubic units. In this case, cubic feet. So again, this is actually the same problem. It's just broken down to the pure mathematics. It says, what is the volume of a right rectangular prism with dimensions 4 feet by 2 feet by 2 feet? Both of these are examples of essentially the same problem. Both are different styles of problems, and your child might be dealing with either one or both of these. They're going to be solved the same way. It's just pulling the necessary information out of this. So let's go ahead and solve that. So Jimmy has a fish tank. I've already drawn it for the sake of time. 4 feet by 2 feet by 2 feet. When we say tall, same as height, just make sure you relate that to your child. Probably already know, but just in case they don't, make sure that when we say tall, this means height. Everything else is already written in wide, width, long, length. So down here, we have length times width times height, our original formula. Volume equals 4 length times 2, that's the width, and then times 2, again, is the height. Now, this breaks down to 8. 4 times 2 is 8, times 2 for the height, and that's 16 feet. Again, remember, 3 multiplied units, that's 3 different numbers, 3 dimensions, gotta put the 3 right here. So 16 feet cubed. Again, same equation right here. We just already had combined for the base. So volume equals base times height. I went ahead and highlighted the base here, highlighted the base here, highlighted the base here in pink. So here we have base, which we already found was 8. 4 times 2, 4 times 2. 8 times 2 equals 16 feet cubed. Same answer, 2 ways to find it. Okay, so now I will show you actually a way that I might prefer to do this. These are called pop cubes. So they come apart. You can order them online. They're only like $13 for I think 100 of them. You can get them on Amazon, Walmart probably, all over the place online. But these guys right here are very good for when you're working with smaller numbers, for literally showing you the units. So I have these right here. They have 4. So we talked about this prism right here being 4 units long, 4 units. So 2 units tall. You're gonna add 2 units tall. But then also we have the width, and we know that it's 2 units wide. So we're going to combine these. And then if you put these together, you can see that, actually, I can attach them. You can see that this is the fish tank, essentially. If you were to physically count the cubes, I can even take them apart, but you can count that there are 16. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. This each represents a cubic foot, since that's our unit right now. This right here is 1 cubic foot of space. So when we put them all together, we have 16 cubic feet of space. This is a really good tool to use if your child is having trouble just visualizing all of this in the first place. And again, with the smaller numbers, it's just a really good concrete way to know at first that when you are doing these mathematics that you are not making those errors. So very easy to double check your work with these. You can take it apart and count cube by cube. Very easy to see if you've missed a cube or something when you made your figure. Just really good resource all around for somebody who might be more of a physical learner with manipulatives rather than simply with drawings and formulas. But we do ultimately want to move towards the formula and move away from the cubes, because the formula will allow us to use those larger numbers easily. If I had a rectangular prism that was something like 30 by 40 by 20, I would not have enough cubes or time to really do that. So again, this is only really practical with the smaller numbers, but it is a very, very good way to get that concrete, basic understanding of the idea down. Okay, so some common misconceptions or misunderstandings that you might run into while your child is trying to learn this is that we have the base here marked, and if you recall, we had talked about how this base is already made up of two numbers, right? So if we're using this formula right here, where volume equals base times height, if you're telling your child that the reason that we use the cubic feet or the 3 versus the 2 for square feet or square units, cubic units, if they're struggling with that, they might think that because you're only multiplying base times height, that's two things, that you use squared. That's not the case, because remember, we always want to go back to the idea that this base comes from two numbers already. So even when you do multiply only two numbers right here, for example, if you're already given the base, you still need to make sure you're using the proper unit. So volume is always going to be cubic units. And one other thing that your child might struggle with is the fact that we are dealing with rectangular prisms here. That is why this length times width times height formula works, or base times height formula works. When we're dealing with other kind of three-dimensional objects, such as a sphere, think about that as a ball. If we're dealing with cones, anything like that, this is not going to apply necessarily. So this is not a volume formula period for all shapes. It's specifically for rectangular prisms and right rectangular prisms. Okay, so that about covers it for our little video today. I hope that you found it helpful. Thank you for watching. I'll throw up a link to buy these in my description of the video so that you guys can find them. Really good tool. So just remember that if you need help, send me a message, leave a comment, something like that, and I'll be happy to try and get back to you. Again, hopefully you enjoyed this video and have a good time.